Hello everyone. Today we're going to study curved mirror and the image formed by mirror. So this one is the convex mirror, and this one is the concave mirror. So this side don't see anything, and this is a screen. We will see why we only have half of the screen. And this is the concave lens, just to compare with the mirrors. And this is a two-side mirror. One side, this side is a flat mirror, and this side is a kinematic mirror. So it's a magnified virtual image. So it must be concave mirror. And we have the same bench we used as last week, and the same light source. So today we're going to study the image formed by a convex mirror. Concave mirror. And you will observe the image formed by a convex mirror. So this part, I'm going to use the bright dot over there to be my distant object, and to find the image formed by this concave mirror. So this is concave mirror, and I have the screen to observe the image. So now the screen is between the object and the mirror, different from thin lens. It's opposite side, because image is formed by reflection. So image and object are the same side of the mirror. Now I'm going to turn off the light. So you see the bright dot over there, and so I'm going to fix the position of the mirror. Only move the position of the screen. Let's see. I don't see anything. It looks like there's a bright dot, so you might want to rotate the mirror a little bit. So now we see the image of the screen, the image of the dot. So I'm going to move a little bit. So it's too far, too close. I think that's the best position. I have a dot, I have a mirror, I have an image. Next, let's read the position. So I have a mirror is exactly at 80 centimeter, image at about 60 centimeter. So the image distance is equal to 20 centimeter for this one. Next, I'm going to use this as my light source and my object. And this is the screen to observe the image, and this is the concave mirror. So actually here I already got an image. So when you adjust the position, I think this is the best image now. So I have a mirror, I have a screen, I have the object. And again, because this image is formed due to reflection light, image and object are the same side of the mirror. So my image distance is from image to the mirror. My object distance is from the object number 4 and the mirror. So my position of the mirror is at 61 centimeter. Position of the image is at 28. So the image distance is 61 minus 28. That's 33 centimeter. My object distance is 61 centimeter minus the object position, that's 10 centimeter. So that will be 51 centimeter. Next, I'm going to try a different position. This time I'm going to increase the object distance. I'm going to move the mirror away from the object. Now let's see. Okay, now there is no image here. Oh, here is the image. Oh, okay. I think that's the best position. This time I have a mirror at 67.6 minus 38.8. Next, I'm going to show you this data. My mirror is at 100 centimeter. Object is at 10 centimeter. So object distance is 90 centimeter. And the image here is at about 75 centimeters. and this is the image distance is 100 minus 70, about 25 centimeter. So if you look at the image, it's number 4, but it's inverted compared to the object. And also the side, it's very small. So as you move further away from the mirror, as the object move further away from the object, from the mirror, the image is still real because we observe them on the screen, and it's reduced inside and it's inverted. Here I have the object distance is between f and 2f from the mirror. Now I have a magnified inversed image behind the object. Now because I rotated the lens, the mirror a little bit to be able to observe the image, so you see the image and the object, they are not the same, and the object and the mirror not on the same axis. Next I'm going to try a very small distance. So for example, I have my object here, I have my mirror about 30 centimeter. So I'm going to adjust the screen and see whether we can find the image. I don't see anything. So you see when the object and the mirror is very close, now it's within 20 centimeters. That's about within the focal length. I can't observe real image. Now let's move on this side. So now I have the object and the mirror, the distance is within the focal length. So I tried different position on the screen, I can't find any image. So there is no real image here, and probably there is a virtual image, but I can't see it here because the object is so large and the mirror itself is very small. So I'm going to try a different mirror. We have a very large concave mirror, and if you look at there, you see my image is inverted. When I go closer, my image gets larger, but then when you go closer, look at that. Now the image is inverted and so large, I can't find my face. Okay, so now I'm close within the focal length. The image is virtual and it's upright. When I move away, the image is inverted, and this one is actually real. I can find it. Next, I want to compare the change of the size of the image. So I want to measure the size of the image here. This is kind of hard to read. I think it's about 1.4 centimeter.